All right, so this video is going to serve as an introduction to function or not. So no math yet, just conceptually. So here we have two vending machines. They both look pretty standard. Looking at the first one, A1 goes to Cheetos, A2 you get Fritos, A3 you get Doritos, A4 you get Cool Ranch Doritos again. And as we keep reading the vending machine, we see everything's fine. It's just a standard vending machine and has rocks in it. But no worries, because you have to pick E1 in order to get rocks or E2 to get rocks. So you know you're getting rocks if you pick those inputs. However, in machine B, it all looks normal. A1, A2, A3, A4, B1, B2, B2. So that's not good, because that means if you put your money in and you select B2, you're not sure. You're going to get Doritos or animal crackers. And then C1, C2, C3, C4, D1, D2, D3, D4, A1. How can that be? We already said A1 would get us the Cheetos, but apparently A1 might also get us rocks. And now we have A2, which also might get us rocks. And C1, where you might pick Funyuns or you might get prunes. So this is our first example of things that are a function and not a function. The definition of a function is that each input has exactly one output. So if we look at our two vending machines, in the first vending machine, every input, every number pattern that you can plug in right here will get you exactly one type of food item or rocks. But this vending machine has a lot of problems. If you hit A1, you might get Cheetos or you might get rocks, which means the input, A1, goes to Cheetos and rocks and makes this not a function. We can also look at these two codes. So message 1 and code 1, 20 is the letter T, 8 is the letter H, 5 is E, and we can keep going. And get a clear message. Because none of these numbers are confusing. A1 is only A, 26 is only a Z, 25 is a Y. The quick brown fox jumped over the lazy dog. Every number had exactly one letter option. But here, the first number it asked me to pick is 14. And so I went to look at my code and I said, okay, it's an F, right? Or N? Or T? And I said, okay, maybe I'll figure it out later. Let's go with the 2. It might be B. It might be H. And I said, okay, now I'm still not sure what to do, but at least 5 only goes to E. So we'll go, okay, maybe it's the, but then we look at this 3 and we see, okay, it might be C and it might be D. So, okay, I'll see what the next number is. I'll try the next one. And I get the 1, which might be A or O or I. So here's again where we hit this problem. The definition of a function, once again, is that each input has exactly one output. So as we can see in code 1, 1 only goes to A. 2 only goes to B, 3 to C, 4 to D, and so on. There's no overlap. But this side, code number 2, certain numbers go to multiple letters, which makes it that input 1 has 3 different outputs. Not a function. But just to be clear on how this works, we need to know again that the definition of a function is that each input has exactly one output. So let's try this code and see if it works. 8 gives me an H. 5 gives me E. 11 is L. 12 is L. 15 is O. 13 is an M. 25 is Y. 14 is N. 1 is A. 20 gives me an M. 5 gives me an E, and so on. But once again, just like my vending machine, where there were 2 spots with Cool Ranch Doritos for outputs, 2 spots with regular Doritos, 2 spots that had animal crackers. Here, 11 only went to L. 12 only went to L. And that's okay. Outputs can repeat as many times as they want. Here, M was 13 and 20. And the letter S has a couple different options. 18, 19, 23, 24. But again, as long as my inputs, the numbers went to only one thing. Outputs, oh, wrong pen. Outputs can repeat. The output doesn't matter, just that the inputs don't repeat. And where's my mouse? Oh, let me fix that. Come on, mouse, where did you go? I can't get it to stop.